Okay, here we go. All right, in this video, first I'm gonna need to make sure that I can mark up, that's what I wanna do. Boom, okay. All right, in this video, we are going to work with mean absolute deviation. Mean absolute deviation measures variability of a data set. Variability of a data set. Okay, so if your mean absolute deviation, or MAD, is closer to 0, then you have no variability. So then the closer you are to 0, you have a little bit of variability. Little bit of variability. And then the bigger and bigger the number gets as it approaches infinity, just a really large number, you'd have a lot of variability. Variability, if I can spell it right, okay, variability comes from variable, right? And variable comes from change. So if you have no change, then your results are really consistent. But if you have a lot of variability, then you have no consistency. Okay, so that's what mean absolute deviation is, or I guess what it measures. How do we find it, though? So to find the mean absolute deviation, we're going to have 3 steps. First, we have to find the mean, and we're going to find the mean, or the average. To do that, you add up all of the data points, and then you divide by the number of data points you had. So as an example, for this first top left box, let's find the mean. So we'd have 60 plus 58 plus 54 plus 56 plus 63 plus 69, and we'd get a number there. Then we would take that number and divide it by however many data points we just added. So we had 1, 2, 3, 4, 5, 6 data points. I am not Superwoman, and I don't remember what that sum is supposed to be. So we're gonna go to the calculator and find out what that's supposed to be. We'll go to the calculator on Schoology. Okay, so on Schoology we're adding a whole lot of numbers. Those numbers are 60, 58, 54, 60 plus 58 plus 54, and there's even more, 56, 63, and 69. So plus 56 plus 63 plus 69. And that sum is 360. So we've got 360. So now we're going to take 360, the sum, and we have to divide it by the number of values that we just added. We just added 6 different values. So we're taking 366 divided by 6, and that quotient is 60. Now that was finding the mean, but our goal today is to find the mean absolute deviation, so we're still not done. The second step is to find the differences. So we're going to subtract with a positive answer. What we're going to subtract is we're going to take the mean minus each data point. So we're going to have as many subtraction problems as we did data points. So in this first example, we had 6 different numbers. We're going to have 6 subtraction problems now. If I asked you the difference between 1 and 5, you would say 4. But 1 minus 5 is negative 4. So when we say differences, remember we're asking for the positive value here. So no matter what, we're going to have a positive value when we subtract, because we're not just finding a subtraction problem, we're really finding the distance between those two numbers. So we want the distance between the mean, which was 60, and the first data point, which was also 60. We want the distance between 60, the mean, and the second data point, 58. The distance between mean 60 and data point 54. The distance between the mean 60 and the data point 56. The distance between the mean 60 and the data point 63. The distance between the mean 60 and the data point 69. Okay, so the difference between 60 and 60 is 0 because they're the same number. The difference between 60 and 58 is 2. The difference between 60 and 54 is 6. The distance between 60 and 56 is 4. The distance between 60 and 63 is 3. And the difference between 60 and 69 is 9. Again, 60 minus 63 would actually be a negative 3, but we're not interested in what's the subtraction here. We're interested in what's the difference between the numbers, what's the distance between those on a number line. And distance is always positive. So we want the positive versions of all those answers. Okay, well, the third and final step is to find the average of those distances. So we're finding the mean, or the average. Again, this time we're using our answers from step 2 though. So we have to add and divide yet again, but this time we're going to use the 6 numbers, or in this case 6, not always 6. In this case, we're going to find the average of the 6 numbers that we just got for the distances. So step 3 is to find the mean again. We're going to take 0 plus 2 plus 6 plus 4 plus 3 plus 9. 0, 2, 4, 0. I can add that in my head, but I do want you guys to get used to using the calculator, and I know some of you would prefer the calculator here. 0, 2, 6, 4, 3, 9, 6, 4. Okay, so those are the numbers. They're not in order. My 4 and 6 are swapped. But the sum is 24. So we've got the sum was equal to 24. So we've done the adding to find the mean again, but now we have to divide. So we have to take 24, the sum, and we have to divide it by the number of things that we just added. Well, we added 1, 2, 3, 4, 5, 4, 5, 1, 2, 3, 4, 5, 6 numbers. Counting is really hard for me today. So we've got 24 divided by 6, which is 4. That's the last step, so our final answer is 4. That is the mean absolute deviation of those numbers. So now we're going to do those again. We're actually going to go this way. So the first step is to find the mean. And to find the mean, I know I have to first do some adding, and then I have to divide. If I were you, I would take a moment and pause the video to add all of these values. Just to conserve time going back and forth, can I pause the recording? Okay. To save time going back and forth, I am going to use a calculator on a different screen that you cannot see. I promise I'm using my calculator just like you guys would. I'm pulling up my calculator now, which you guys can't see. Okay, so we've got 5.8. My calculator's pulled up now. 5.8 plus 6.1 plus 5.5 plus 6.6 plus 7.3 plus 5.9 plus 6.3 again. Okay, so when we sum all of those numbers, we have 43 and a half. So when we added, we got 43 and a half. But to find the mean, we have to add and also divide. So now we're going to divide 43 and a half divided by as many numbers that we just added. We added 1, 2, 3, 4, 5, 6, 7 numbers. So we're going to do 43.5 divided by 7. And we get a really lengthy decimal. I'm going to round to the third decimal place for now. Normally in 8th grade, we have to leave our final answer rounded to the second decimal place. So if I make sure I'm always rounding to my third decimal place, then I should be good to go on the rounding front on my final answer. So I've got 6.214. The second step here took care of the absolute part of mean absolute deviation because we're finding a positive answer. We're concerned about the distance, which is always positive. What we're going to do is we're going to take the mean, 6.214, and we're going to have a bunch of minus problems. We're using the mean minus each data point, so that minus 5.8. We're going to have 6.214 minus 6.1. We'll have 6.214 minus 5.5. 6.214 minus 6.6, and so on. I would pause the video and see if you can't do the subtraction on your own. Or you can wait at least until I'm done writing everything and then pause the video. Minus 6.3. So all I've done is I've made a list of subtraction problems. The first number in my subtraction problem came from the mean, and the second number in my subtraction problem came from these data points. And now I'm going to subtract. So I need 6.214 minus 5.8, which is 0.414. I need 6.214 minus 6.1, which is 0.114. It's 6.214 minus 5.5, which is 0.714, 714 thousandths. I need 6.214 minus 6 6/10. That's a negative answer, but because we're concerned about the distance, which is always positive, I'm going to ignore the negative sign and just write 386 thousandths. Then I need 6.214 minus 7.3. Again, this answer is negative, but I'm concerned about distance, which is always positive. So I'm using the positive version of my answer, which is 1 86 thousandths. Now I've got 6.214 minus 5.9, which is 314 thousandths. And then I have 6.214 minus 6.3 or 6 3/10. That is 86 thousandths. Okay, last, third, and final step is to find the mean again. So now I have to add up all of those values, and then I'll divide by 1, 2, 3, 4, 5, 6, 7. Okay, so to add all of those values, we're going to need 0.414 plus 0.114 plus 0.714 plus 0.386 plus 1.086 plus 0.314 plus 0.086 all added together. Take a minute and do those. Add that up on your calculator. We've got 0.414 plus 0.114 plus 0.714 plus 0.386. This is a lot of just typing in calculators. Plus 0.086. Okay, when we add all of that together, we get 3.114, or 3 and 114 thousandths. And now we have to divide that by 7. We took care of the adding of all of our numbers from step 2. Now we have to divide by however many numbers there were, which was 7. So we're taking, I'm going to write sideways now because I'm running out of room. 3.11, actually, I'm not going to write sideways. I'm going to stay organized. I'll just move below my page. Okay, so now we've got 3.114 all divided by 7. Okay. 3 and 114 thousandths divided by 7 is 0.4448. If I were typing this in on a STAR test or on a regular math test, my calculator would probably want, or my program that I'm typing things in on would only want probably 2 decimal places. So I've got 0.44 or 44 hundredths. Behind 44 hundredths is a 4, which means I'm closer to 44 hundredths than I am 45 hundredths. So my final answer for this example is 44 hundredths, and that is the mean absolute deviation of those 7 numbers. Okay, now I think we've got a pretty good handle, maybe at least, on what the steps are. So I'm gonna move over to the side and we will do 2 more examples. So we've got the first step, we'll do the top right box. The first step is to find the mean, and to find the mean we have to add and divide. So we're adding 46. We're adding 46 plus 47 plus 56. I'm just reading my list of numbers from here. Plus 48 plus 46 plus 52 plus 57 plus 52 again plus 45. Take a moment, if you haven't already, type that in on your calculator, pause the video. Hopefully you've paused the video. When you type all of that in your calculator, you should have got 449. Okay, that's just the first step for adding all of the data points. But to find the mean or the average, you have to add and divide. So now we're going to take 449, the sum of all of those data points, and we're going to divide by the number of data points we had. That's 1, 2, 3, 4, 5, 6, 7, 8, 9 data points. So we have 449 divided by 9, which is 49.88888. I'm going to change this to a fraction so I don't have to keep rounding. This is 449 over 9. Okay, the second step, we were using green. The second step is to find the differences And when we said differences, we really meant the distance, so the positive version of whatever answer we had. So I'm just going to write this really big because I don't want to keep writing it over and over and over. 449 over 9 minus 46 minus 47 minus 56, right? I'm making a list of all of these subtraction problems here. Minus 57. Okay. It's minus 52 again. Minus 45. Okay. So the first subtraction problem is 449 over 9 minus 46, which is about 3.889 if I round. Then I'll have 449 ninths minus 47, which is 2.889 if I'm rounding to the thousandths place. I would take a moment and pause the video and try to work with the rest of the subtraction problems on your own. And that's what I'm going to do right now too. So maybe we can just sit in silence together. Okay, if you haven't finished all the subtraction problems yet, do pause the video and get to a place where you're there. Hopefully you have finished it. I've starred a few of these problems. I've just put a star near them. Those are the ones where I got a negative answer, but because I'm finding the difference or the distance on the number line, I wrote down without the negative sign because distances are always positive. Now that I have all of the differences, I'm going to use these numbers and a pen, not a highlighter. I'm going to use the numbers from step 2, all of these distances. And I'm going to find the mean or the average of those. Again, okay. So we're going to have to add all of those up. So we'll have 3.889. I'm going to type this as I say it. 3.889 plus 2.889 plus 6.111 plus 1.889 plus 3 and 889 thousandths plus 2 and 111 thousandths plus 7 and 111 thousandths plus 2 and 111 thousandths again, and that's because we had 52 written twice. I had to repeat it because 52 is 2 separate data points, so I have to use it twice. And it was continuing on, plus 4 and 889 thousandths. Okay, so when we add all of our distances from step 2, we get a sum of 34 and 889 thousandths. That's just adding though, that's not finding the mean. because finding the mean or the average would mean we have to add and divide. So now we're going to take 34.889 and divide it by the number of data points we just added, which was 1, 2, 3, 4, 5, 6, 7, 8, 9. Fun fact, in Texas, we're supposed to be able to do this for up to 10 data points. So if you feel pretty confident with this, when we have 9 points, I'm pretty sure you're good to go on this front. 3, my pen turned off. Alright, the quotient of 34,889 thousandths divided by 9 is 3.8765, and the 5 repeats. Okay, so let's say we want to round this. We're going to probably have to round to the hundredths. So I know I've got 87 behind the decimal. Behind 87 hundredths is a 6, which means 87 is much closer to being 88. So our final answer for this mean absolute deviation is 3 and 88 hundredths. Okay. In class, I did have you guys, hopefully I had you guys worked on this one on your own. If you're curious about that example and you would like to know the answers and see the steps all written out, you can log on to Schoology, find the completed notes, PDFs, and look at this example. If you have any further questions, comments, or concerns, please do not hesitate to reach out to me via Schoology.